All right, there we go. Number 6. Right triangle, hypotenuse 9, one angle 37. Find the lengths of each leg. Well, let's give it a try. Be helpful to draw yourself a little triangle. So right triangle. Hypotenuse is 9. One angle's 37. Doesn't matter which one, whatever. I'll just say like that one. Or you could make that bottom right one. It doesn't matter. I'll just make that one 37 because that one looks smaller. But whatever. Find the length of the other two legs. So let's call this one X and this one Y or whatever you want, just giving them names. Joe and Tom, whatever. Okay, so can you find those two? Find X, find Y. You should calculate. This would be on the calculator part. You can use your calculator because 37 degrees is not one of our memorized angles, right? So let's start with X. So when you're looking at X, you're thinking, okay, what kind of trig relationship involves 37, X, and 9? That's how you want to look at it, right? When you're thinking, am I going to do sine, cosine, tangent? What am I going to do? What trig relationship involves the 37 degrees, the X, and the 9? Good job. Sine, huh? Sine. That's opposite over hypotenuse on that? Yeah. Sine. Remember the whole SOHCAHTOA, here I'll write it up here, the whole SOHCAHTOA, right? Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So sine is opposite over, this is the hypotenuse, right? So sine is opposite over hypotenuse, so the sine of 37 degrees is the opposite. That'd be the X over the 9, huh? That makes sense there? So we can solve that easily enough for the X. Just multiply both sides by 9 on that. So I just go, okay, X over 9, and then just multiply both sides by the 9, and then those cancel. And so we get X equals 9 sine 37. Somebody have that in their calculator? Round to the 10th, so just one decimal place. Just one place. 5.4? Yeah, because he says 10th place here, so just one place. So 5.4, so we got X. Now, let's go get Y. How do we get Y? You could do Pythagorean. If you're going to use a rounded number, though, like if we're going to use the 5.4 here, you better use a couple more places of accuracy so that the Y comes out. Yeah, so why don't you give me two more? 5.4, 1.6? Okay, yeah. So if you want to use that, or you could just go back and do the cosine of 37, and that'd be the Y over the 9. Either way is fine. So yeah, maybe I'll just do Pythagorean. So X squared plus Y squared is 9 squared, so the X is 5 point. But like I said, if you're going to use a rounded number, use a couple more decimal places than they want in the end, right? Because it'll, otherwise, you need more accuracy in the middle to get the right answer in the end. So what's that going to be? 81, and then whatever. Can I just go dot, 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 just crank that out and get your answer for Y. Either way, or you could have done the cosine 37 thing. That would have worked, to get Y. That would have worked also. Good? That's easy stuff. You could have done that before this class started, huh? You knew that already from trig. I bet. All right. All right. Suppose you're headed toward a plateau, 50 meters high. That'd be like, like you're cruising, and then there's like a mountain up ahead or something. So you're here, getting the idea what they're doing. This is the plateau. A plateau is a flat spot, like on a mountain, right? It just means a flat, raised up spot, right? So you're walking along, and you see this plateau up ahead, And it's 50 meters high. So you know this is 50 meters high. And the angle of elevation to the top of the plateau is 20 degrees. What's the angle of elevation? That means from where you're at, whoops, I missed a little bit, to the top of the plateau there, that is 20. That's called angle of elevation. That means, elevated from the horizontal, right? So there's flat, horizontal, and then there's how far you got to go up for elevation. Does that make sense? Angle of elevate, how much elevated above flat? Above 0 degrees, right? So 20 degrees, 50 meters high, right triangle. And what do they want me to find? How far are you from the base of the plateau? Yeah, so they want to know this x here. Or call it d for distance, or whatever you want to call it. They want that, huh? They want to know how far we are. So if you're looking off in the distance at a plateau and you know it's a 50 meters tall hill or whatever, and then you do the angle is 20 degrees. There's an instrument that does the angle, sextant, isn't that what it is? Where you look through the thing and there's like a sight, and then it tells you the angle you're looking at, right? You've heard of that kind of thing. So anyway, so you can do that. You can, they do that with, I don't know what they use. I'm sure they use lasers now for surveying. But they probably used to use the sextant and get the angle, but now it's just all laser done, I think, when they're surveying things. But yeah, get that angle. So can we find x in that situation? Let me give you a second. Try that one. Yeah, that one could be a little tricky. Be worth your while to crank it out. What relationship connects the 20 degree, the 50, and the x? Tangent, huh? Yeah. Because tangent is opposite. Tangent is opposite over adjacent, so katoa. So tangent of 20 then is what? 50 over x? Isn't that good? Now, people get confused here. Like I said, 30% of the class often, maybe 20%, I don't know, messes that up in the finals. They just divide by the 50. That's not right. Right? Remember I showed that yesterday, didn't I? So what do? Just put this over 1, just go diagonal. When the x is on the bottom, you got to get it back up to the top, right? So watch out for that mistake. So x tan 20 is 50 times 1, or just 50. So x tan 20 is just 50. Divide by the tan 20. There it is. And then just hit the buttons on your calculator. You'll get x. Reminds me of I thought it was a very funny story. Years ago, it was 5-6 years ago, something like that. I was teaching summer school, and I remember it was in the middle of summer. I got back to my office after teaching in the afternoon, and I checked my phone messages. I had a message, so I played my phone message, and it said, "Hello." Did it say my first name, Brett? I think so. "Hello, Brett. This is Hank Smith," or whatever. I can't remember the name. "This is Hank Smith. I'm out here at this survey site, and I'm looking at this. We got this big tree we got to take out, and I'm not sure. There's two sizes on some big equipment they bring out, a backhoe or some giant. There's a medium and there's a large, and we don't know which one to get. We can't tell if that tree's 100 foot tall or is 150. We're right now we're 100 yards from the base, and the angle on my sextant thing is 35 degrees. Can you tell me how? Is it how tall is that tree? Here's my phone number, And I remember I listened to the message and I thought, Hank, I don't remember what the name was. Hank Smith? Hank Smith, I still remember. Hank Smith, I still remember. So anyway, I called the number back, and I go, "Hello, yeah, this is Brett Heron from Fresno City College." "Oh, yeah." He goes right in. "Yeah, hi, Brett. I'm out here." He just starts in the spiel right away. I'm like, "Oh, what? Hold on. I'm sorry. Just a second, Hank. I'm sorry." I said, I'm sorry, but I don't remember where I know you from." And he goes, "Oh, you don't know me? You don't know me?" And I'm like, "Oh, how'd you get this?" He's like, "I just called the city college up. And I thought, I got a math problem. Can you get me through to a math teacher?" That's so funny. I thought, yeah, I guess so. We're here to serve the community. So I solved this problem for him and told him the answer. Anyway, this is kind of funny. Just call up the community college, dial in, get a math problem solved. So funny. All right. So one more question. Might be worth our time. This will be our last problem, and then we'll review. All right. State trooper is hitting 30 feet from the highway. 1 second after a truck passes. Angle between the highway and the line of observation is measured. Okay. Whatever. Okay. What are they talking about? Angle is 13. So this angle there, I guess, 13. How fast is the truck? How are we going to figure out how fast the truck is traveling? Press the answer in feet per second. So feet per, oh, it's 1 second. So if I can find feet, then divide by 1, so that'll be feet per second. So I got to find feet. Oh yeah, so it's just the same thing. I just got to find x, you know, how far this is. That'll be feet, right? They give me the angle's 13 degrees here. And so 30, x, and 13. What trig relationship connects the 13 degrees, the 30, and the x? Tangent again, right? So it's just tangent of 13 degrees is 30. Same thing we did a minute ago. 30 over x, right? Just like that. Cross multiply, zip, zip. X tangent 13 is 1 times 30. And so x tan 13 is 30. Divide by tan 13. Tan 13. And so that'll be x. And that will be the feet per second because he does that many feet in 1 second, right? So that will be his speed in feet per second. So whatever that comes out to be. Is there a, somebody have that? What's 30 over tan 13? To 2 decimal places. 54.79? 64.79? No? Make sure you're in degree mode. It's easy to accidentally be in the wrong mode. Anybody got a different answer? 129.94? Okay, let's go 2 places. 129.94. Let's go back and... Okay, so now part B says miles per hour. How do we change? This is feet per second. How do you change feet per second to miles per hour? Yeah, you can grab, you have a conversion chart or Google or something, you know, but I'll show you step by step if you want. If you're going to take chemistry or something like that, you do a lot of unit conversion, so I'll just, we don't got a lot of time. I better get to review. I could waste too much time here. But I'll just do one real quick. You write it like that. It's that many feet per 1 second. Write it as a big old fraction. Multiply. Now, you just keep being motivated by what you want to get rid of. We want to go to what? What's my final goal? It's miles. In the end, I want miles on the top and hours on the bottom. That's what miles per hour means, right? So if I want, do I want to keep seconds or get rid of them? Get rid of them. You don't want seconds in, you want hours. So if you want to get rid of seconds and they're currently on the bottom, where are you going to put them? On the top, and then seconds will cancel. See how you're every step you're moved by what you want to get rid of. Seconds, what can I convert easily? I mean, I could do hours, but that wouldn't be, I'd have to think. What do I just know right off the top of my head? Seconds to minutes, right? What do I know? 1 minute, 60 seconds. Y'all know that. So if I stop the problem right now, I'm in feet per minute. See, that's all that's left. Seconds are gone. I'm in feet per minute. Well, I don't want feet per minute. I don't want minutes on the bottom. I want to get rid of minutes, so put minutes on the top. Bye-bye minutes. What can I go to easily? Hours. What do I know? 1 hour, 60 minutes, right? If I stop the problem right now, I'm in feet per hour. I got the bottom part right. Now I got to get miles up there, and I don't want feet. So put feet down here. Bye-bye feet. See how why did I put the bottom first here? Because I'm trying to get rid of feet now, right? Top to bottom. Now, this one you may or may not know. 1 mile is how many feet? Yeah, I'm impressed. All right, 5,280 feet. So 5,280 feet in 1 mile. So there you go. That's how you do conversion. When we take chemistry and stuff, that's how you convert units. So anyway, so what that means is all the numbers on the top you multiply, numbers on the bottom you divide. So just take the 129.94 times 60 divided by 5280. And it will be that 88, whatever we saw a second ago. Was it 88 something? 88.6? There we go. All right. There we go. I'm not going to put that on the test, but there we go. That's the class. Let's go to review. You guys got that copy down? We got half an hour, and then we got tomorrow. We definitely need to review. All right. So I can't copy and paste them, but I can just write them down as we go. Yeah, I should get them up so I can do that tomorrow. Okay. Anyway. All right. So let's go back to graphing. I'm looking at exam 1A, part 1. So I'll give you both versions, so you'll have the A and the B, whether you took the A or the B version. in class. So f of x, number one, is f of x equals minus x cubed minus 2. And it says find the central. It wants you to graph, find the central point and one other point. So this is 1a, number one. They give you a big old, axis system there, and they want you to graph. So let me give you a second. Graph that thing. So first thing is you want to have in your mind, what is the basic look of x cubed? He's the snake one, right? He's the snake. He goes from low to high, right? They all go lower left to upper right, don't they? At least originally, if they've not been flipped or moved or something. Originally. Lower left to upper right, it does a snake thing. But then figure out, well, actually, you don't need to figure everything out. Remember we made tables? Remember how to do that? So what you do to do these is just go ahead and, let me just, there, okay. Just make a table, and then we do the central first. How do we find the central point when we do this graph? It's for all the graphs. How do we do it on these graphs? Whatever makes the x zone 0. Now, in this case, the x zone is just x. But if we'd had like x plus 3 cubed, then that would be the whole zone, and I would plug in -3 to make that 0. But in this case, x is just x, so it's just 0. You with me on that? Remember the x zone? Like if I had square root of x plus 7 minus 4 or something, I would plug in -7 for x because that's what would make his zone 0. Remember that? Plugging in whatever makes x's zone 0. Because that'll be the middle. That's where the new center is. When you plug that in, what do you get? This is y. Remember, f is y. It says y equals minus x cubed minus 2. So that'd be what? Minus 0 cubed minus 2. It's just going to be minus 2, right? So over 0 down 2, boom. There's the center of the snake. Right? It moved from the origin to there. Right? Now, you need one other. How do you always find the one other point? Just add 1. Yeah, take whatever your center was and add 1. There's one case in which adding 1 won't work and you have to subtract 1 instead. But adding 1 almost always works. So add 1, plug that in. -1 cubed minus 2. What's that? Minus 1 minus 2 minus 3. Over 1 down 3. There is the other dot. Good? So what do we know? It must go like this. It's been flipped upside down. That's because that minus right there flipped it, There it is. That's all you need to do. Central point, one other point. Remember that? Kind of stuff. Questions on that one? Let's see. Yeah, let's do the hardest one. Questions there? We good? All right. I'm going to move on to number 3. So I'm on 1A Part 1 exam, question number 3. So if you took 1B, that's okay. In a couple days here, you'll have all these questions as well. You have both versions. So, all right. So f of x equals square root of 3 minus x plus 2. Same thing. Graph it. Central. One other.
It's not on the screen.
Oh, it's funny. Just didn't reset. Okay, and graph it. Hello there. All right. So there it is. So there's the function. You want to find the central, comma, one other point. Do the graph. There it is. See what you can do. It's important to note how far that square root goes, right? The square root's over the 3 minus x, but it's not over the 2, right? That matters a lot. And what is the basic look of a square root graph? Yeah, good, William. You remember my analogy even. My stories don't go on total deaf ears. I'm glad to hear that. It's a little firework. That's how I think. It looks like a firework because it's the only one that stops one direction. So it looks like you just set it on the ground and it shot off, It doesn't go left and right, in other words. It only goes one. If it's flipped, it'll go left or whatever, but it only goes one direction. It's the only one of the basic 6 that doesn't go both ways. It's got a stopping point. All right, so we got to do the xy table. Y is square root of 3 minus x plus 2. Got to find the central point and one other. So what am I going to plug in to find the central point? 3. Whatever you plug in 4x, whatever will make the x zone, x's little world, 0, that'll be 3, yeah. So y equals the square root of 3 minus 3 plus 2. That'll be 2, won't it? Why did I write 0? 2. Right? We good with that? 0 plus 2, it's 2. Okay, so that means over 3 up 2. 1, 2, 3, 1, 2. There, over 3 up 2, is the center. That's the center of the firework thing, right? Now, you got to find one other. Normally, we add 1. That's not going to work, is it? Because if you put in 4, you get the square root of 3 minus 4 plus 2. That's the square root of negative 1. That's no. So you just write no. Yeah, going to subtract 1. So right, because square root of negative 1 is an error. The calculator will say error. So it's still important information. I'm still going to go over to 4 here and say no. That means the right side, that graph does not go to the right at all. That's helpful information. But anyway, so the adding 1 here, the adding 1 didn't work. So then you go back and subtract 1, plug in 2. Instead of the original 3, add 1 to 4, you subtract 1 to 2. Does that make sense? So we're always taking the original central point, and we're either adding 1, 99% of the time we just add 1. If that doesn't work, you subtract 1. 2. Plug that in. So plug in 2, what do we get? Y equals the square root of 3 minus 2 plus 2. Y equals root 1 plus 2. That's 3. So over 2 up 3 right here. Good? Over 2 up 3. Got our 2 dots? Now, here's some mistakes I see a lot on the test. Let me show you. So you've got those 2 dots. We know it's a firework kind of thing. Watch out. I see this a lot. People will go, okay, I got it. Why is that wrong? What are they doing wrong there?
They didn't start this.
Yeah, who's supposed to start? This guy. He's the central point. They started with the other one. Right? So it matters. Those dots have unique roles. They're not just 2 dots that are the same in equivalent roles. They have special roles. The starter must be the starter. So you got to start with this guy. Now, just like that, right? No, that's wrong too. What's wrong with that? Yeah, remember they're slow growth, not fast growth, right? Square root graph. So no, it's supposed to go like this. It's supposed to be concave down. Now I'm not going to take off a lot. I'll take off 1 or 2 if you have the wrong concavity. So we'll take off a little. You move it into calculus, you'll have a second derivative. Will tell you concavity. You'll deal with concavity. That concavity means like a bowl turned down or a bowl turned up. Fast growth or slow growth, right? Remember, square roots are all slow growing things. Square rooting, right? Square root of 100 is just 10. It's not getting big very fast. Whereas powers like x squared, put 100 into that thing. What's that? 10,000. Right? Put 100 into square root of x, you're only at 10, right? Much slower growth. So it's important to know, all the square root ones, all the root ones are bowls turned down. All the power ones are bowls turned up, aren't they? So you want to keep that straight. There we go. Questions on that? Good? All right. So there's part 1. Let's go to part 2. Part 2, let me see, which one looks good? Graphing utility, okay, I can do that. Number 1, so this is 1A part 2, question number 1. And we're looking at 2x to the 4th plus 7x equals 5x squared plus 14. Plus 14, it says use graphing utility. All right. What are we supposed to do when it says use graphing utility? You could. There's a couple ways to go. It might be easy. That'll certainly work. That is one way. Put it all on one side. Or you could just let this be y1 and let that be y2 in your calculator. And then do the intersecting, right? You got to hit second. So put in y1, put in y1 equals 2x to the 4th plus 7x. Put y2 is 5x squared plus 14. Then hit, so I have to do that, then hit second, what is it? Second calc or something? Second calc.
Second trace. Second trace, which is
No, it is, second trace. Oh, it's above the trace key. Oh, yeah, thank you, yeah. Second calc, yeah, right. Second calc or second trace, right, same thing. And then you gotta, what do you do from there? I'm forgetting it all. Where does it go? When you hit second calc, does it go to, what menu does it go? Oh, then you gotta choose intersect, right? Then it goes down to intersect. Yeah, go down to intersect, choose intersect, and then you can just hit enter. The first two questions, don't worry about it. Just hit enter. This is on the TI anyway. Casio's a little different, a little easier really. Hit enter, and then there's going to be two intersections when you graph it. Oh, first you have to graph it, huh? I should have said graph it, then hit second calc, then choose intersect, then hit enter. And then you have to, there's going to be two intersection points, right? Get close to one of them and hit your third enter. Close to one intersection. Intersection. And hit enter. And then close to the second intersection and hit enter. Well, actually, you have to redo the whole process for the second intersection. So the two answers you should get, negative 2.31 and 1.69. X equals. Can you get those? Are you getting those? Negative 2.31 and positive 1.69. So we get those two X values from the calculator. Is that working out? Two intersections. Check there. Yeah, if you're having trouble, come up, grab me after class. Probably just take 10 seconds. Be glad to help you. I better move on so we can get as much possible done. So I'm going to move on. There's the answers. Write those down or whatever. Well, they'll be on the key. I'll give you in a couple days. Well, maybe even tomorrow. Let's see. So let's move on. Try to do the major things. Here's 1A, part 2, question 2. F of x equals minus 2x to the fourth minus x squared. And they're asking, is it even, odd, or neither? Do you remember how to determine if a function is even, odd, or neither? Been a long time. So you can write, you get a full sheet of notes, right, for the final, write all these down. Well, you'll probably can't write everything down, but you know, whatever you need to remember, write it down on that full sheet of notes. As you go through the practice exams, or the old exams, that'd be the best way to prepare your study sheet. You know what I mean? Don't just wait till the night before and then write down whatever's on the top of your mind. As you're doing the old exams, make your study sheet. Anyway, what you do is you plug in negative x for x. Remember how to test even oddness? You plug in negative x for x, step 1. Simplify. And if the answer is equal to the original, then it's even. If the answer equals negative 1 times the original, it's odd, otherwise neither. So there it is. So you got to plug in negative x for the original x, parentheses negative x for the original x, simplify it, and then see, does the simplified answer equal the original? That's even. Is it negative 1 times the original? That's odd. Otherwise, it's neither. So you can put that in your 3x5 card. No, full sheet of notes for the final exam. All right, let's do it. So I'm going to come up here. I'm going to put in negative x. Everybody good to there? I just plugged in negative x in the two spots there was an x. Right? I just took this and I put in negative x. That's the first thing you do. Plug in negative x with parentheses around it. Okay? And then simplify that however you can. So how is this first piece here going to simplify? You got a negative 2 and a negative x to the fourth. That negative x to the fourth, 4 of those is going to become positive, times the negative 2 is negative 2x to the fourth, right? Minus, and then the minus x squared becomes positive as well. But the other subtraction, the subtractions in the front still sit there, don't they? We good to there? So the minuses that were in the parentheses vanish because those are even powers. If they were odd, they would stay, right? So there's the simplified answer. So how does that compare to the original? Same. So it's even. It's an even function. And even comes from x squared, x, even powers, we're not surprised. Right? If you're thinking, can I just look at it, even powers, it's even? Well, they can be a little more tricky. They can mix even with odd. They can do some trickier things. So you better do this test to be sure. Good on that one? So I probably don't have time to do another. Number 3's similar, test even odd. Well, maybe I'll do it real quick. See, I want to do everything tonight, and I'm not getting enough stuff. All right, I'll do it real quick. This one, even odd, neither. What is it? Well, plug in negative x. So negative x up here, negative x here, right? And now simplify. So simplify. What happens? Well, that negative stays. The one on the bottom becomes positive. So how does this compare to the original? This is the answer. This is the original. Everybody good so far? I just took the original, plugged in negative x in both the x slots, simplified. How does the original compare to the answer? Do you see it's odd? Because it's negative 1. Right? The original times negative 1 is the answer. You might say, yeah, but that negative 1's on the top. Well, that's the whole deal with a fraction, right? When you multiply by negative 1, that negative can go to the top only or the bottom only, but not both. That good? So it's, yeah, that's odd. That one's odd. Because of this negative right here. That's the negative 1. Right? It multiplied the top by negative 1. So some people think, no, Mr. Herman, I remember this was a question I got a lot after exam 1. People would say, wait, when you multiply by negative 1, you're supposed to multiply the top and the bottom. That's not true. Important that you know that going into calculus, right? If I take just think about a fraction, 2/3. If I want to multiply him by negative 1, it wouldn't be right to multiply top and bottom. That'd be positive 2/3 again. That's not right. You multiply the top only, or you multiply the bottom only. Or you put it in the front. That's fine. But you don't put it top and bottom. You don't do it twice. 2 negatives would be positive. Make sense? So since they have the negative on the top, that is negative of the original. That's right. Right? Okay. So let me see. Yeah, here's a good one. Here again, 1A, part 2, number 4. F of x equals negative x plus 3 if x is less than 2, 2x minus 3 if x is greater than or equal to 2. Graph it. Can you graph that one? Give you a big axis system there. Remember these are called piecewise. You do them in pieces. Remember that? A little bit? Here, let me do this. So 2 is the big dividing line, right? So 1, 2. I suggest a dotted line there. You don't have to. But it might help you look at it right. Right? 2, x is positive 2. It's going to be like two graphs. One of them left of 2, one of them right of 2. Does that make sense? We have a table. So in other words, we have minus x plus 3 when you're left of 2. So over here, I'll do y equals minus x plus 3. And then over here, I'll do y equals 2x minus 3, right of 2. Make sense? We have this equation to the right of 2 and this equation to the left of 2. Huh? That's what it's saying. It's saying two different equations in two different territories. Whether you're left of 2 or right of 2. Okay, so what do you do? Well, those are both linear, aren't they? Those are both linear equations. They're both x and y to the first power. That means linear, means the graph's going to be a line, which means I only need 2 dots. 2 dots connect the line. So I just come over here and make a little x, y table real quick. Just plug in any values you want. How about, oh, you should always plug in the border. The border is 2, right? You need to plug in 2, and then some other point. How about 1? Whatever. The border is important, though. You got to see how they connect up or don't connect up at the border, right? Got to see what's happening at the border. So I'm going to plug in 2. Now, you might, if I was you, I'd be thinking, wait a minute, that says x less than 2. This is supposed to be for x less than 2. It's not equal to 2. You can't do 2, right? That's a good point. So circle that 2. Remember, my suggestion was just to circle it to remind yourself it's going to be an open dot there. But don't just skip it. It's going to get infinitesimally close to x equals 2, right? It'll get to 1.99999, so it's basically going to get to 2. So you need a value at 2. Just make it an open dot, because it doesn't really hit there. So plug in 2. What do you get? This is minus x plus 3. So minus 2 plus 3, 1. So 2, 1 over 2, up 1, open dot. Head over 2, up 1. And then plug in 1. What do you get? Minus 1 plus 3, 2. Over 1, up 2. Here's 2. Whoops. There it is. There's that half of the graph. Good on that half? Just connected those 2 dots. Right, this is over 1, up 2. This is over 2, up 1. Connect the 2 dots, open dot at the border there. Now, for the right graph, same kind of thing. X, Y table. Got to do the border. Plug in 2 and then whatever else you want, like 3. Now, notice I'm only plugging in x values on his side of the wall, 2 and 3. I'm not plugging in 2 and 1. He doesn't go that way. He's to the right. Plug in 2, you get 2 times 2 minus 3, 4 minus 3, 1. And plug in 3, you get 2 times 3 is 6 minus 3, 3. Over 2, up 1. Look, he fills in. And over 3, up 3. It's way up here. He's going up fast. So he's 3, 3. Over 2, up 1. So that ends up being a solid dot on the border because the blue fills in the red, huh? So they connect up like Legos. Perfectly. Yeah.
So when you graph it, it doesn't matter if you have the circle or the open circle and the separate continuous?
No, in the end, it's nothing.
Okay.
Yeah. But I might give you one in the final, I don't even remember, that hits down here or something. And so that other one remains an open dot, you know? So if that open dot wasn't filled in, then it would be important to keep it. Piecewise graphs. Make sense? 2 different pieces? So just keep the left and the right straight on those. All right, I'm going to move on, get a couple bit more done here. How about number 1A, part 2 still. Number 5 gives you f of x equals x cubed minus 4x squared plus 6. They want a max, local max it says. So basically you just graph on your calculator. It says use the graphing utility, your calculator. So you graph the thing. I don't even know what it looks like, but whatever. Let's just say it does like this. Whatever. Just make something up. So they want the local max. The local max would be right there, huh? So you do second, you graph it, then you hit second. Okay, you graph first, and you hit second calc, and you choose max, and you go left of the spot, like somewhere over here, left of it, right of it, and then enter on the third one. So you go left of it, right of it, and then enter on it. So I'm going to leave that, and you find it. The value for the local max is 0, comma 6. You might get something funny. Your calculator might tell you like 1.32 e minus 7 or something, comma 6. That means 0. Do you realize that means 0? It's just the calculator's lameness. It means this decimal needs to go back 7 places, which is 0.0000132. It's 0. The calculator's just plugging numbers fast. It's the calculator's best ability to say 0. If you get that kind of weird thing, e minus 7, that means decimal back 7, or exponent, or however your calculator shows it. That's basically 0. It's just the calculator just runs numbers fast. Is all it does. Anyway, so I'm going to leave that. If you have trouble with that, come see me. Be glad to help you with calculator stuff. Let's go to, you guys got that down? Okay, you can always check this out later. I'm going to move fast. Number 6, I'm still on. Keep reminding where I'm at. 1A part 2. 1A part 2, number 6. Domain. It asks for the domain of x over square root of x minus 5. Give you a second. Just remember about domain. We've done a lot of domain, haven't we? You guys are domain and range experts. We know how to do domains and ranges on graphs. How do you do domain of a function? Remember, we're looking for trouble spots, right? Like where, it's kind of like what can't go in the toaster? Can't put knives in the toaster. Shouldn't put tinfoil in the microwave. Like what should you not plug into that function? What's a problem area? Inside of a square, yeah. So remember, we have square roots inside of any root. You take out for domain. Let me just write some instructions here. For domain, if you have the inside of any root, say inside a root, you got to be greater than or equal to 0. You can't be negative. Can't have negative in there. And also, if you have like a, whatever, blah 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 over a denom, then you say denom, you cannot be equal to 0. That says 0 there. I didn't know mine was off the screen. And you solve. Denom not equal to 0. Yeah, so those are the two things we usually look for domain issues. Inside of a root, can't be negative. Bottom of a fraction, denominator can't be 0. Right? So this one is both. He's both in a root and he's in the denominator. So he's greater than or equal to 0 because he's inside a root, but no way on the equal 0 because he's also a denominator which cannot equal 0. So it turns out to be it's just strictly greater than 0. It can't be equal to 0. See how that's a combo one? So then solve, jump the 5 over, x is greater than 5, done. Or interval notation, 5 to infinity, parentheses. Same thing. Good? Questions on that? Remember domain? Square roots, denominators on that. Let's squeeze out one more. Be good to there. You guys got that down? Can I flash off of it? All right. 1A part 2, number 7. We got a little more than halfway through. So, all right. So f of x equals, I should have a little more room here. X squared plus 7x plus 8. Find f of x plus h minus f of x all of h. Let me write a note. You know how I'm always secretive about what I'm going to put on tests and everything. I'm kidding. I'm obvious and clear. Will be on the final exam for sure. Why? Because the first thing you're going to do in Calculus 1, difference quotients. That's a difference quotient. It's a difference fraction, basically. So I want you guys coming out of the gate in Calc 1, ready to go. That's the first thing you're going to do is a bunch of those. So let's make sure you do it. That will for sure be on the final. Give it a try. You got a minute and a half. So you could do it in pieces if you want. F of x plus h, what does that mean? Plug in x plus h. I'm just going to do it all at once, I think. Yeah, let's just do that. So here is f of x plus h here is f of x. Everybody see what I did there? So I plugged in x plus h to the whole function, minus, and then parentheses, because why parentheses? Because you want to subtract all of f of x. If you don't put the parentheses, you're only subtracting the front part of f of x. We're supposed to subtract all of f of x, said the formula. All right, and then crank that out with your algebra skills, which you'll need all of them for calculus. Good to there? Now, let me give you a hint here. All non-H terms will cancel. Remember that when you're in Calculus 1, 5A, this summer or next fall. So this summer it'll be 2 weeks, huh? You do it this summer or next fall. When you do a bunch of these, you'll do like 50 of these different expressions. All the non-H terms will cancel. It's a good way to double check you haven't made any mistakes. So for example, x squared, he doesn't have an h. He better cancel. I'm sure of it. Yep. There he goes. Any term without an h will cancel. 7x, he doesn't got an h. He better cancel. Yep, sure enough, there he goes. Who else up there doesn't have an h? The 8s. See how all the non-h terms will cancel every time, guaranteed. So what do we have left? 2xh plus h squared plus 7h all over h. Then you can cancel. Remember, you cancel 1 from each of these guys. And so what's left? 2x plus h plus 7. No more denominator. Oh, that's off the screen, huh? Yeah. I kind of ran out of room. So the answer, the final answer is right here. 2x plus h plus 7. All right. One more day of review. I'll get your exams back for you tomorrow. And we'll complete our review. Have a good day.